is a disassembled XJ1100, a 1983 model, which I am in the process of. If you look closely, anybody recognize the snail-shaped part? Perhaps from this angle is easier to see that it is in fact a turbocharger from a, believe it was around an early 2000s Audi A4 1.8 liter, which I'm in the process of trying to fit to this motorcycle, this 1100cc displacement 4-cylinder engine. So they're not closely matched as far as displacements go. I'm trying to fit a 1.8 liter to a 1.1 liter. I'm just hoping that the engine produces enough flow that I can spin that to speed within a reasonable RPM range. I'm thinking my results will be pretty good. Positioned and made custom brackets right here to hold the turbo in the orientation that you see it, as well as here. This one I made out of 1.5 1/8 inch thick flat bar, which I bent in a U shape almost to the exact position where it meets the frame. So that turbo's in there pretty solid. It's just tacked at the moment, but that will be the final orientation of the turbo. So it's going to be a tight fit to try and put everything into here. I hope in the coming weeks that I'll be able to put it all together, and I'll document it as best as I can. I decided on the orientation of the turbo because I'm actually going to bring the headers from the left side, pipe it into the turbo here, and on the right side have it leave the turbo at the exit, wrap back around and down under where it'll go to the tailpipe. That's the plan anyway. We'll see how it goes. Throughout this process, I'll try and document it as well as I can. So one of the issues in attempting to turbocharge this motorcycle is the 1.1 liter 1100cc engine is actually a 9.3 to 1 compression ratio. You can actually turbocharge a very high compression ratio engine, but only within reason. You can't really put too much boost into the engine without having a pre-ignition or knocking going on. So at most, maybe I could get 4 or 5 psi at absolute most, and that's if I tune it correctly with the spark, advance, retard, or fuel injection, which is difficult. That raises another issue entirely. The bike is actually factory carbureted. It's not fuel injected. So that it's another custom manufacturing that I have to do in the intake manifold as well. But as it stands now, the compression ratio is the biggest issue I think I'm going to try and tackle at the moment. I am going to remove the cylinder head and put in place of the head gasket a thicker head gasket to try and reduce the compression ratio to say an 8.5 or 8 to 1 compression ratio, which I'll be able to easily boost up to 12 or 14 psi if I do it right. Getting that turbo out was quite the ordeal because I opted to install studs here because I thought on the reverse side, having the limited clearance, it'd be easier to try and slip a nut on to tighten it up. But those studs, when inserted into those holes, gave such a reduced degree of freedom for this turbo assembly to move about, and it basically jammed itself between this fabricated bracket at an 45 some degree angle and this fabricated bracket 45 some degree angle, despite the fact that all fasteners were removed. So it just sat there, and I was trying to wiggle it, trying to get those studs out. Ultimately, I might opt to remove those studs entirely and put just bolts through here and have the difficult time to try and put the bolts. Maybe it'd be easier, I'm not actually sure. Or I might actually drill those holes just a slight bit larger. Maybe it'll slip past that bracket there and line up be able to insert the studs through the larger holes, but I'm not really sure at the moment. In any case, I did remove the turbo, and the back brackets are still holding in place, just tacked as they are. And I took the liberty of removing the bolts to hold this valve cover in place. There it goes, just from the other side. And we have the intake exhaust cam and chain. I'll set this down here somewhere. Looks immaculately clean. I'm liking that so far. Let's remove the cover that exposes the ignition rotor timing. And there are two markings on it, as you can sort of see. It says C and T, so I wasn't sure which to align with the number 1 cylinder. So I took the spark plug out with this little light that I have here, observed the piston approaching top dead center with both the lobes off the valve. So I know it's the number 1's in the compression stroke. Then I rotated not on this side, but on this side, where I removed the other cover, exposing the alternator. This is a very nice bolt head that I used a socket and ratchet to rotate through on this side while observing this side. And sure enough, the C mark came into alignment as it approached top dead center. So it's just a little off. I'm going to fix that here shortly, and then I'll start taking off the bolts for the chain tensioner on this side, chain tensioner down there, the chain guide, as well as the sprockets, which are on the other side. So I just jammed the cam sprocket so I can exert some torque on these bolts here. They now thread out. But before you remove those two that are underneath, you have to remove the tensioner, which I believe is that right there, the timing chain tensioner. So removing this here, it's a spring. I was able to remove it past that bar, sitting right there. A little bit of oil started dripping on my pavement, so I had to get an oil pan in a hurry. Keeps things interesting, which means that the crank has to complete a full rotation, which is 360 degrees, because the cam moves at half the rotational speed as does the crank, which I have now done, bringing the other two bolts into sight. So removing those bolts, or the last two, might be wise to mark index marks on the cams so that upon reassembly we know the rotational position that these cams should be with the crank not changed. I mean, worst comes to worst, we can re-index the number 1 cylinder top dead center and position the cams so that it's on its compression firing stroke, but just seems easier to mark stuff as you take it apart. As you can see, with a nice big paint marker, I marked the location of the cam gear with respect to the camshaft chain tensioner. I didn't realize the crank head moved a few degrees, so I'll just have to remember that. It's maybe a couple degrees past the alignment mark when it comes time to reassemble. Should be fine though. But of course, as I just discovered, with the cam gears free to rotate as you remove the last bolt, they will rotate on the cam as well. So perhaps it's possible to index the cam 180 degrees. They index the cam gear 180 degrees off the mark. So the mark between the guide and the gear is not sufficient. You have to mark the gear with the cam. And I didn't do that before I moved it, but I'm going to try and line up. I didn't do that before I moved it, but I'm trying to line up that hole and just put a paint mark on the cam itself. It's worth noting for anybody that's tackling a cylinder head on one of these XJ or XS1100 bikes, there are hidden bolts, or nuts I should say, that need to be removed here, here, and here, just below the carburetor assembly. It's already been removed, as well as one right here above the camshaft chain tensioner where it resided. So be sure to get those out before you try and remove this with any kind of force. Here we have the cylinder head removed, and regrettably the chain disappeared into the crankcase. I'll have to fish that out later with a magnetic pickup tool or something of that nature. And here is the cylinder head and the very important sought after gasket. I'm hoping that I can pick one up that has an increased thickness that I'll effectively be able to reduce the compression ratio on this engine. However, if not, maybe I need machining something custom, which I'm not really keen about. It's incredibly costly. Alternatives, maybe stack 2 gaskets up on top of each other, or 3 gaskets. That's just asking for trouble, I imagine, but I'm trying to keep costs low. I'm going to have to figure this one out. I don't want to spend a lot of money. Hopefully I don't have to. So just a physical check to make sure that none of the valves are actually sticking. I did it on removal, just checking on installation at the moment on this particular one to demonstrate. But they all check out. Upon removing them, I checked every single one. So it's just a matter of cleaning it all up now and reassembling it. And then this cylinder head will be good to go, because looking at the valve seat wear pattern, on the intakes anyway, you can't quite see. Well, I can tilt the head. We can look at the exhausts as well. I mean, it doesn't look uneven. It looks pretty uniform across the perimeter of each of the ports, right? And as it does on the valves as well. Looking at the margins on the and that's pretty typical of all the valves. I mean, it looks pretty good. I mean, this one is a little bit, I mean, you see how it gets narrow a little and then wide as you rotate it the other way? Maybe by a couple thousandths. I mean, it's not bad. Maybe just slightly. I mean, it's okay though. I mean, it's relatively center on the face of the edge of the valve, so I mean, it's good. In any case, before I disassembled the head, I did a compression check, and I got pretty even compression across all cylinders. So, I mean, I'm not concerned about the valves not sealing. They're doing their job. And they move freely within all the valve guides of the cylinder head. And the valve seals, they don't seem loose or sloppy around the valve stems, so I'm not going to remove them, I'm not going to replace them. I just don't want to spend too much money on this project, but they all seem pretty good. I mean, there's no reason to remove or replace them, unless something obvious, I guess. I mean, if you have the funds, for sure, but economic recession the world's going through right now, or will be going through, why waste your money? They're good. The intake combustion chambers had all been cleaned up so far. All the carbon's gone. That was quite a bit of work to do. Involved a lot of elbow grease. I find WD-40 works pretty good, as well as arguably a 50-50 mix of acetone and transmission fluid, oddly enough. Still took about 3 hours of scrubbing. You have to be really careful on aluminum parts. I did use this stainless steel, which worked the best, with light pressure. You don't want to put scratches or scrapes across the surface of any of the combustion chambers or head gasket area. Next, I'll be lapping the valves. The order in which I removed them, as I later had to review the video that you're seeing now, was for the exhaust valves, which are the smaller diameters, was 1, 2, 3, 4. And then the larger intake ones, according to cylinder number, was 4, 3, 2, 1. So I've kept the order. I've moved them from the egg carton you saw previous to the bath of solvent to help clean them up. This side is the intake side. I've removed the intake boots since. So I will be putting a bit of this lapping compound on each of the margins of the valve and lapping them to their correct location seat. Bit of motorcycle oil for the stems of each of the valves. Smaller exhaust valves, 1, 2, 3, 4. Larger intake valves, 4, 3, 2, 1. This being cylinder, this is the intake side here. So cylinders 1, or combustion chamber 1, 2, 3, 4. 1, 2, 3, 4. This valve lapping compound just need a little bit. That might even be too much. In order to keep things clean and separate, the darker one to wipe the valve stem of any oil, should I need it. This one to wipe any of the grit, the abrasive, because we certainly don't want any abrasive on the valve stem as we slide it into the valve guide. 1, 2, 3, 4. 1, 1. Next, we want to use some brake clean to clean off all that grit abrasive left on the combustion chambers with the valves in place. Try and get rid of as much of that as possible because we don't want that falling into the valve guides. One, two, three, four. One, two, three, hard to see in the camera, the lighting, but it's a slightly darker margin to the valve where it's seated to the valve seat. You can definitely see here a darker margin around the valve edge. I call that pretty good. I'd call that pretty good. 4, 3, 2, 1. 1, 2, 3, 4. 4, 3, 2, 1. 1, 1. I've reinstalled the cylinder head with a 1/8 inch aluminum bar as a spacer or shim, as I'm planning the thickness of the gasket. Because the machine shop here in town says they don't have 0.093 inch, they have 1/8 inch available. Got a few different quotes from several different machines shops. The best price one says they only have 1/8. And just thought I'd reassemble the cylinder head just to make sure that timing chain, which I suspected might not have enough length to accommodate a 1/8 gap. The issue that I was running into as to why they were not fitting initially is because the cams were not bolted down here at the end. They were floating off the bearing surface because of the spring force of the valve pushing it up. The lobe of the cam has to, at one of the cylinders, press down on the bucket and shim to press the valve into the cylinder. So I actually indexed the cylinders so that they're all away from top dead center, so that when I bolted these caps on, push the valves open, they wouldn't hit the pistons. Before installing the head, make sure that all your pistons are indexed below the top of the cylinder, so that when you install the head and the cams, they don't push the valves into your pistons, possibly causing damage. Making sure that all your pistons are below the deck of the top of the block will ensure that when those valves open, they open just into air. So before installing the head, make sure that you do that if you're going to install the cams, because one of the lobes of the cams is going to press the valve open. And after bolting the cams down so they sit on all their bearing surfaces, 1/8 inch space between the block and the head still allows plenty of slack in the chain. And I placed a 1/8 inch bar, or 1/8 thickness bar, to simulate the thickness of the gasket that will go between the block and the cylinder head, as you can see through the gap here. Then, just to make sure that the perimeter, just to make sure that the cam timing chain will fit, because the raised distance of the head away from the block, some engines, they actually might, the chain might not be long enough to allow for an increased distance. So this particular engine, either by design or by the very fact of the stretch of the chain through the years of operation perhaps, because timing chains do stretch, there is more than ample chain to allow a 1/8 inch gap. So a 1/8 inch gasket will work, which will leave me the compression ratio of, I believe, around 7.5 to 1, which is quite low. Means that before that turbo spools up, this motorcycle is going to be a very slow as molasses machine off the line, which I'm not thrilled about. Maybe I can compensate for that with some nitrous, but that's a very expensive system as well that I'm not sure I want to spend the money on just yet. So the thing about that is, if I use the 1/8 gasket to give me a 7.5 to 1, when that turbo kicks in, I can add a lot of boost. I have to check the charts. I'm thinking probably 12 to 14 pounds boost, which will really cause this machine to accelerate once that turbo kicks in. Scary acceleration. If that's the goal, then maybe a 1/8 is the way to go. I think a .093 inch is more desirable, personally, because an 8.4 compression ratio still allows some low-end acceleration before the turbo kicks in without nitrous, so it won't be quite as fast, and I'll have to dial down the boost, but something to consider, something to think about. But a 1/8 will work. So the machine shop that has quoted me for the gasket says they have 1/8. I'll consider it. I'm not sure.